Hello class, so our next set of question is this. We start with this question. It says resolve into partial fractions. So we have this set of problem. So with partial fractions we have one for linear factors, repeated factors, quadratic and improper factors. So you can let me know in the comment section if we need to look at each type of resolving of partial fractions. Then I can also make an independent video of that. So this is a linear factor kind of question. So with this one, we just go straight forward into splitting it. So we'll say this is equal to, we'll have a over x plus 2 for this denominator, then the other one will be b over x minus 1. Then from here, when we multiply, common denominator we multiply, we'll have a multiplying x minus 1, and then b will multiply x plus 2. Then we equate this with the numerator, which is 4. Then we can expand that. We'll have 4 is equal to ax minus a, the first expansion, plus, when b multiplies inside, we'll have bx plus 2b. Then we can collect like terms, those with x and those with which are constants. So we'll have 4 is equal to ax plus bx. We've collected those with b, or with x, sorry. Then the constants we have, we'll start with the positive 2b minus a, so that at least it looks nice. Then we can factor out the x here. So we have 4 is equal to x, we factor out x, then we have a plus b, then plus 2b minus a. Then we're going to equate. We can think of this x, let me just write it here. We can think of this x here. Okay, so this is more of an expression. So this 4 also has an x in form of 0x plus 4. It has an x by the side, and then this is equal to a plus b, x plus 2b minus a. So it has x, it's not changing anything, this is just 0. So we'll equate this one with the coefficient x with the 0 here, which is a coefficient for this x. And then we'll equate the 2b minus a, which is a constant, with a constant 4. Let's do that. So we'll have a plus b is equal to 0. Then we'll have 2b minus a, which we can write as negative a plus 2b is equal to, it's equating with the 4. So we've equated the coefficient of this x with the 0. So it's a plus b is equal to 0, and then this constant with 4, which is here. And this is a simultaneous equation. So we can just add it, giving us, this is a 0. This will be 3b is equal to 0 plus 4 is just 4. So our b is equal to 3 over 4. Then we can replace this b in, let's say, this one. So this will give us a plus 3b is equal to 0, which is just a is equal to negative, sorry, this is not b, this is 4. Okay, so negative 3 over 4. So now that we have the solution, we can rewrite the expression. So we're looking at 4 over x plus 2, x minus 1. So now this is equal to, so where there was a, we'll replace with negative 3 over 4 x plus 2 plus, then we'll have 3 over 4 x minus 1. So I don't have space here. Okay, so we'll have x minus 1, that. and this is our solution. This is how you present your solution. Okay, so we can proceed. So this is our next question that we need to resolve into a partial fraction. So when you look at the exponent that the numerator is having, it's having a greater exponent than our denominator. So this is an improper factor kind of question. So before we resolve into a partial, first we need to divide, so at least we get rid of the aspect of it being an improper fraction. So we use the method of long division. So we'll write the x squared minus 4. This is dividing into x cubic plus x squared plus x plus 1. So I divide in that. So x squared into x cubic, we're going to have x. So x multiplied by x squared will have x cubic. Now, what do we put here? Because when we multiply x by -4, it's going to give us -4x, and the value for x is this part. So which means on this part, we're going to put variables like 0x squared. This is just a 0, but we need to represent it to match with what is on top. Then the x multiplied by -4 is what we'll put here, -4x, so that at least every variable has a partner there. Then now we can subtract. So the subtraction of the two, this is 0. This is 0. No, this is not 0. This is x squared minus this 0. So we'll have x squared. Then x minus 4x. So it will be x plus 4x, which is 5x. Then we can continue dividing. So x squared into x squared will have a positive 1. 1 times x squared will have x squared. 1 times -4 will have a -4. So we don't have a partner for this, so I have to add the 0x. Then 1 times -4 will have a -4 there. Then we bring down this positive 1, so that each variable has a partner there. Then we'll subtract this. So this is a 0. 5x minus 0, it will just be 5x. Then 1 minus, so it will be 1 plus 4, which is, we'll have 5 there. So now x squared cannot go into 5x, so we've gotten rid of the aspect of the numerator having a greater exponent than the denominator. So this can't go into this, so we end here. So we have this as our solution, the answer that we've obtained, and this 5x plus 5 is our remainder. So we can represent it now as, so we're going to write the expression. So we've simplified it. We've simplified it to this. So it will now be equal to our answer that we obtained on the numerator, which is x plus 1. So we'll have x plus 1, which is on this is our answer here. Then we're going to continue by adding also this, which is our remainder, plus 5 over this denominator, which is x squared minus 4. So this is what we've obtained. Then here, when we look at what we have on our denominator, this is an expression that can be split. We can do some factorizing here. It's a quadratic actually, so we can work around it by factoring out what needs to be factored, since it's more reducible, we can say. So we'll take this part only. and work it out. So this is, we have 5x plus 5 over x squared minus 4. So the denominator can be worked out as, it's a difference of 2 squares. So we'll have x minus 2 and x plus 2. So we reduced it. Now this part, we can now work on it. It has become more of a linear factor on the numerator, so we can work it out. So this is just taking this part, working around this part. So we're saying we can have it, okay, is there space here? If I was to say we have space here, we'll have a over x minus 2 plus b over x plus 2. Okay. Then, getting the denominator there, we'll have a multiplying with x plus 2, b multiplying with x minus 2, and we equate with the numerator. So we'll have 5x plus 5 is equal to a x plus 2 plus b x minus 2. Then we can work around it. We can multiply the a throughout. So we'll have 5x plus 5 is equal to ax plus 2a. Then b and x will have bx. Then b and negative 2 have 2 negative 2b, like that. We can collect the terms with x together and the constants alone. So we'll have 5x plus 5 is equal to ax plus bx, then the 2a minus, so we'll have plus 2a minus 2b. Then we can factor out the x here, so we'll have 5x plus 5 is equal to, we factor out the x, we'll have a plus b, and the x there, plus 2a minus 2b. Then we can equate what we have on the left hand side and the right hand side. So the x factor, it has this as a coefficient, this one has 5 as the coefficient, so we equate them. So we have a plus b is equal to this 5 here. We've taken coefficients. Then this is a constant 5, we equate it with 2a minus 2b. So we're having 2a minus 2b is equal to 5. We can work around it now. So we can make this one have a 2. So let's say we multiply throughout by 2. It will become 2a plus 2b is equal to 10. Then 2a minus 2b is equal to 5. Then we can subtract throughout. So these will cancel. Then we'll have 2b minus 2b, which is addition, which is 4b, is equal to 10 plus 5 is 15. So our b is equal to 15 over 4. We can't reduce it further, it will become, we're avoiding decimals. Then we can replace this 15 over 4 in the first one before we had simplified it. So we'll have a plus 15 over 4 is equal to 5. Then we'll have a is equal to 5 minus 15 over 4, which is a is equal to, so a is 5 over 4. So when you solve it, it will be 5 over 4. Then we need to go and write it. We write it from our in our expression that we found. Okay, so we had this expression, so we're going to just replace it as, so our a is 5 over 4, so our 5x minus 2 plus, we have 15 over 4, which is 15 over 4, which is x plus 2. So this is just one part. Then we need to write the final solution now of everything, which is of this one. We need now to include this part, x plus 1. So our final solution will look as, which is the final answer of everything we've done. So getting the final expression, we're going to finalize it, which is going to be, so we have x plus 1, the one we had found at first. Then we will include these now. So we're getting it all from here now. First we had done the long division, we got x plus 1. Then we had to work on this part. So now that we found this, we can combine everything. So we'll have x plus 1 plus 5 over 4 x minus 2 plus, okay, my space is done, so the other one will be 15 over 4 then x plus 2. Okay, I'll try to make your work at least smart, not the way I've written it, so at least it should fit on one page, but this is it, then we're done. So we're solving this question now. So we have this one which says solve the inequalities. So we have the first one, which is x squared minus x is less than 12, which we're starting with. So solving this inequality, which is x squared minus x less than 12, this is a quadratic when you look at it, so we'll get the 12 cross the equal sign. We'll have x squared minus x minus 12, which is less than 0. So here we will get this is a polynomial, actually a quadratic, and equate it to 0, so that we can find the zeros of this polynomial. So which is x squared minus x minus 12, we say is equal to 0. We find the zeros of this polynomial. So which is, if we use the zero, we can solve this quadratic by either the quadratic formula or the product sum method. So if we use the product sum method, the product is negative 12, the sum is negative 1. The two numbers that we can add to give us negative 1 are negative 4 and 3. And if we multiply them, they will give us this negative 12. So we'll say x squared minus plus 3x minus 4x minus 12 is equal to 0. Then we can group the terms. So if we group this and we group this, then we factorize. So here when we factorize, we'll get x, and then we'll have x plus 3. Here when we factorize, we get negative 4, then we'll have x plus 3, and this is equal to 0. Then when we factorize with the x plus 3, we will get x plus 3 like that. We remain with x minus 4, which is equal to 0. Then we can use the zero product rule, so we're having x plus 3 is equal to 0 and x minus 4 is equal to 0. So this is x is equal to negative 3, and this is x equal to positive 4. So these are more of our critical values that are making the polynomial 0. So since we have them, we're going to test them to see if they qualify for our inequality. So we'll draw the number line. So at the far end we'll have negative infinity and we'll have positive infinity. Then we have a positive 4 and we have a negative 3. So these are our sections of trying. So we'll start with the negative here. So negative 3 all the way to negative infinity. We pick a number. So we'll pick negative 4. So we replace negative 4 here. So if we put negative 4 here, okay, let me just solve it so at least we have something concrete. So we'll have negative 4 plus 3, and we'll have negative 4 minus 4. This is giving us a negative 1, and this is giving us negative 8. When we multiply the two, it's giving us a positive. So here we're obtaining a positive. We come to this region, negative 3 all the way to 4. So there's a 0 in between here, so we'll take the 0 and replace it. So wherever there is x, so we'll have 0 plus 3 and 0 minus 4. So we'll have 3 multiplying negative 4, that's a negative. So here in between, we're having a negative. Then we have the region now 4 all the way to infinity, we'll pick 5. So replacing, so we're replacing the values here, by the way, if you're missing it. So we place 5 here and 5 there. So we'll have 5 plus 3, and we also have 5 minus 4. So 5 plus 3 is 8, 5 minus 4 is 1. So these are positive, so we're getting a positive here. So this is a positive. So if you look at the question, how it was phrased, the inequality says less than 0. So less than is negative, so this one does not qualify, this one qualifies, this one does not qualify. So our range of values are negative 3 less than x less than 4, because it qualifies. So let me just put it here to indicate to you. So our answer is negative 3 less than x, which is less than 4. The range of values between this point are the interval that we need. So with that, we've solved this question. We can go to the next one. So our next question is x minus 4 over x plus 1 less than 0. So this is a rational inequality. So this is a rational inequality. We're going to get the critical values first. So critical values we have, we'll get x minus 4 and set it equal to 0. So this is just x is equal to positive 4. And we also have x plus 1 is equal to 0. And x is equal to negative 1. So remember, this is the denominator. So x should never be equal to negative 1, because if it's equal to negative 1, then we'll have a 0 on the denominator, which is making the function to be undefined. For x is equal to 4, it's fine. We can have a 0 on the numerator. There's no problem. So now that we have these two values, we're going to test them. So our testing is, this is positive infinity, negative infinity. The two values that we have is, we have a negative 1 and we have a positive 4. So we have 3 regions we're going to try out. Let's start with the first one, negative infinity all the way to negative 1. What number should we pick? So we take negative 2. So we get negative 2 and replace it. Remember, the function we're dealing with is this one, x minus 4 over x plus 1. X minus 4 over x plus 1. So we're going to replace, we're starting with negative 2. So when we replace negative 2, we have negative 2 minus 4 over negative 2 plus 1. So this is giving us negative 6 over negative 1. When we divide, we're getting a positive number. So this region has a positive. We try for negative, we are on the region negative 1 to 4, so there's a 0 here. So we try a 0. So when we put 0 where there is x, we'll have 0 minus 4 over 0 plus 1. So 1 into negative 4 is just a negative. We're getting a negative number. So the answer there is a negative. Now the last region, which is 4 all the way to infinity, we'll pick 5. So we're trying for 5 now. So wherever there is x, we replace with 5. So we'll have 5 minus 4 over 5 plus 1. So we have 1 over 6, which is a positive number. So on this region, we're having a positive. So we look at the question, how it was phrased. It was less than 0. So if it's less than, then this part is true, which is a negative. So our region is negative 1 less than x less than 4. This is our region. If we're to present it in interval notation, we can have it as negative 1 and also 4 there. Then it's done. Let me know in the comment section if we need more questions to do with inequalities. Hello class. So we have this question: find the term which is independent of x in the expansion of x cubic minus 2 over x squared 15. So to work out this question, we will use this formula, which is t r plus 1 is equal to n combination r, then we have a n minus 1, sorry, n minus r, then b raised to r. So looking at this expression that we have, we can identify that a is equal to x raised to 3, our b is equal to negative 2 over x squared, and then our n is equal to 15. So the value for r we don't know, so we have to look for this. So now we can replace what we know into our formula. So this will be now t r plus 1 is equal to, for n we'll put 15 combination r, then a we replace with x raised to 3, x raised to 3, we'll put it in brackets because there is n minus r, then our b is negative 2 over x squared, then all this with exponent r. We simplify, so we have 15 combination r, so the 3 will multiply with n minus r, so we'll have x raised to 3n minus 3r, then we're having the r can also multiply with the exponent for 2 and the exponent for x, so that we have negative 2 raised to r over, so the r is affecting negative 2, as then we have x raised to 2r. When we reach here, we need to take this x squared to become a numerator there. So this is equal to, so 15 combination r, we'll have x raised to 3n minus 3r, then the x will go to the numerator, so we'll end up having negative 2 raised to r, and we also have x, so when it goes to become a numerator, it will become negative 2r, like that. So these three terms are multiplying, So this x can multiply with this, and since they have the same base, we'll add the exponents. So we'll have 15 combination r, then we'll have x 3n minus 3r. So we'll add with this exponent, so it will just be negative 2r. Then we have maintained the negative 2 raised to r. We can simplify this. Which will give us 3n, then negative 3r minus 2r will give us negative 5r, then we have negative 2, then r there. Then the question says we look for the term which is independent of x. So the term independent of x is x raised to 0. So we equate what we have here, this part, to x raised to 0. So I'll just write it down here. We're changing, so we've just taken this part. So we're saying x 3n minus 5r, we equate this to x raised to 0. So when remember the indices, since we have the same base, we just equate the exponent. So it's going to be 3n minus 5r is equal to 0. Okay, and one thing in class we failed to replace. N, we said it's 15, if you remember. Sorry. So n is 15. So wherever there is n, we had changed with inside. So we need to put 15 here. So it's 15 minus 5r is equal to 0, which is going to be 45 minus 5r is equal to 0. Then we'll have negative 5r is equal to negative 45, which will just be r is equal to positive 9 when we divide negative 5. So we found the value of r to be 9. Now that we have the value of r to be 9, we replace it now, so that we replace it here at this stage, so that we get the final answer. So I've taken this part, this is what we're replacing in. So we'll start with t. So we'll say t of 9 plus 1, which is 10. So we can just put 10 there. So we'll put 10 is equal to 15 combination 9. Then x, we had said this is 40, this is 15. Remember n here is it's 15, so 3 by 15 is 45 minus, so this is negative 5r. So when we put 5 multiplying with 9, we're getting a 45 again. And then this is negative 2 raised to 9. So we've replaced wherever there is r, we put a 9. So t of 10 is equal to 15 combination 9. So this will be 0. So x raised to 0 is 1. I'm sure you remember this principle. X raised to 0 is 1. So we're applying this. So we just have negative 2 raised to 9. So you can simplify it further, but you can just leave it here, it's fine. So this is just negative 2 raised to 9 combination 15 combination 9 here, and this is your final solution. So you should also let me know if we should do more examples on independent of x, but this is it.